Hi everyone, welcome to class again. My name is Lily. I'm from San Diego, California in the USA, and welcome back. So now we're going to be going over energy, part of the Standard 6 curriculum. So first of all, I want to give a little review of this week. So on Monday, we were talking about what is energy, right? And the different forms of energy. Then on Tuesday, it dealt with the law of conservation of energy. Wednesday, we went over different types of energy resources, renewable, non-renewable, and then we're going to see that again today. And then Thursday, the long-term effects of energy usage. So this week, we went over energy, right? And on Friday, that's review day. So we're going to be reviewing those concepts that you saw in your activities. So first of all, our first section deals with energy in its different forms, specifically potential and kinetic energy. So you can categorize energy as either potential energy or kinetic energy. Now, what exactly does that mean? So, first of all, let's review what energy is. Energy is all around us. It's what makes things move or do work, which includes us, right? And so, a couple examples are the sun. The sun has so much energy. It's literally a whole ball of energy. And during photosynthesis, plants harness the energy from the sun and store it as sugars. So it's going to absorb the light into their leaves and they're going to use that light to create an energy source like glucose or sugars. Now, when we eat the plant, when we eat those sugars and the glucose, that's where we get our own energy sources from the plants. And so energy in our cells fuel us to move us around and do work. So where do our cells get that energy? Our cells get that energy from the food that we eat. And so energy can change its form and can be transferred. Now, this brings us to the law of conservation of energy. And the law states that energy cannot ever be created nor destroyed. And this means that we can't make new energy, and we can't get rid of energy either. The whole universe has a whole supply of energy, and this energy cannot be destroyed, and you can't make new energy. Energy is constantly being recycled and transferred into new forms. And so let's start off with potential energy. Now, potential energy is the energy that comes from Earth's gravity, and it's based on how heavy the object is and how high it is from the ground. So if I had an object that was over here and an object that's over here, this object has more potential energy than this object because it's higher off the ground. Like if you were to drop this object from this height, it would have more energy going down than the energy that this ball contains, right? And so, or object, whatever you want to call it. And so, the higher the object is, the more potential energy it has. And a boulder at the top of a cliff has potential energy. So does a soccer ball when it's held above the ground. If I were to hold my pen over here above the ground, or above my desk, right? It has potential energy because if I were to let go of it, its potential energy is going to be turning into kinetic energy as it's moving down, right? So potential energy is up here based on the position. So higher potential energy, lower potential energy. So that's the idea of it. Now we're going to be talking about kinetic energy, and I talked a little bit about kinetic energy with this pen over here, right? If I were to let go of this and let it fall to the ground, this would be falling down, right? And that would mean that the pen is moving. So kinetic energy is any energy that comes from motion. You have a moving car, a flying bird, a bouncing ball. All of those objects have kinetic energy. How do we know that? We know that because it's moving. If you see something moving, it has kinetic energy, right? And the faster something moves, the faster it goes, the more kinetic energy it has. And so right here, I'm moving this pen, right? And so the energy from my muscles, right, to move my hand is getting transferred to this pen. Now this pen is moving. Do you see the energy transfer? And if I were to like drop it or throw it, I'd be adding energy, right? If this pen stayed over here at rest, It has only potential energy, no kinetic energy. It needs an outside force to give it energy. And so in this case, it would be my muscles, right? So my muscles are contracting right now. And if we go even farther, do you know why my hand is moving and how it's able to move? Well, it's using the energy stored in my food, right? My cells are using the energy stored in my food to move. And so this is what energy does. You see the effect of energy. Energy makes things move. Energy makes things do things, right? So over here, energy from my wrist goes into the pen, and then I don't want to throw it, right? Because it'll make a lot of noise and I don't want to make a mess. But if I were to throw this, this would the pen is just gonna go flying into the air until it falls down, and you'll hear it land, and then it's gonna have a little thump sound, right? So I'm gonna drop it right now. You heard that? So this potential energy, a lot of it was converted into sound energy, what we hear. And so this is how energy is transferred. And we're going to be exploring the different types of energy in more detail. So this is from kinetic to potential energy. We're going to specifically look at the relationship. So at the bottom of this diagram, the picture, we have kinetic energy. And the biker, as it's moving up the hill, it has kinetic energy because it's moving. Once the biker is getting to the top, it has the maximum potential energy. So once this biker is moving higher and higher, higher, it's getting higher and higher in the hill right over here, right? It's moving higher. The potential energy is getting higher and higher and higher. Then once the biker is at the top of the hill, he stops for a bit, right? And so he has no kinetic energy. He's at the very top. He can't move any higher, right? So he stops. And so now you have maximum potential energy and less kinetic energy. Now over here, as the biker goes down, it's moving, right? So the biker has kinetic energy now. He's moving down until he gets to the bottom. And once the biker gets to the bottom of the hill, he's going to have zero potential energy. And the kinetic energy is going to be at its maximum, right? Because he reaches the very bottom and he's moving even faster. As you're going down the hill, it's going to go faster and faster and faster, right? Have you ever ridden your bike downhill? Or maybe have you been in a car and the car was moving down a hill? So that you'd notice that you were speeding up, right, as you're going downhill. And so anytime this biker is moving, he has kinetic energy. And anytime he's going higher and higher and higher, there's going to be more and more potential energy until you get to the maximum where you're at the highest. So this has the highest potential energy. And when you're going down, your potential energy is also going to go down. Now we have the different types of kinetic and potential energy. So we have different types of kinetic energy. Kinetic energy like electric energy, radiant energy from light. There's also thermal energy, which is heat energy. So if anything that's really hot, like steaming hot soup, that has a lot of energy because it's really hot. There's sound energy, and from the little pen demonstration, when I dropped this pen onto the ground, right, all of that kinetic energy turned into sound energy with that little boom, right? And then we have mechanical energy, which is just things moving. Like if I'm moving my hand here, I'm using mechanical energy. It's moving. All these different parts are moving. Now we're going to get into potential energy. So potential energy is like elastic energy, first of all. So I don't have a slinky with me right now, but if you ever seen like those coiled slinkies, they can expand and contract. If any of you guys have curly hair and it has like the little coils, if you like stretch it out a bit, you're increasing the potential energy, right? So if you have really curly hair, my sisters, they have super curly hair. And if I were to take like a little strand of hair, I can just like extend it a little bit, right? The curl, and then when you let go of the curl, it's gonna bounce up. It's like a little boing, right? Then we have chemical energy, which is the energy stored in our food, right? Our food contains energy, right? Remember the producers, the plants, where did that energy come from? Take a moment to think where that energy came from in your plants. Okay, so now that you got a little bit of time to think for yourselves on where that energy came from, you should have arrived at the conclusion that that energy came from the sun, right? Everything comes from the sun, all of your energy, because the sun is like a big ball of energy. And then we also have nuclear energy, which is produced in nuclear power plants. And this is based on the little atoms. Like if you're going into the different little atoms, you're going to zoom into one atom and then go into the nucleus of it. You can create energy from there. Now it's a little bit more complicated. You don't have to get very far over there, but maybe some of you guys know a little bit about nuclear energy and atoms. And then the next one's gravitational energy, and that's just another fancy word of the gravitational word for gravitational potential energy. Basically, it's just what the whole pen and bike thing, right? So the higher something is, the more potential energy it has, right? If you're going against the force of gravity, and so the higher it is, the more it's gonna fall, right? It's just common logic. Like if I drop my pen from here, it's not gonna fall as much as if it were from up here. So the concept of potential and kinetic energy aren't that difficult to grasp, even though they're a little bit abstract. If you think about it that way, potential energy based on your position, where you are at, your height over here, that's what it means. Kinetic energy, just thinking about things moving, that's also what it means. And so let's actually try out some energy transfer. So one is rubbing your hands briskly together. So if you rub like this, you keep rubbing it, right? You feel your hands are getting warmer and warmer and warmer. I want everybody to try this. Rub your hands like this, right? Do you feel it getting warmer? So this is your kinetic energy from your muscles turning into heat energy, thermal energy, which is another type of kinetic energy, and it keeps you nice and warm, right? And again, the other energy transfers, if I were to drop an object, right, its kinetic energy is going to turn into sound energy when it hits the surface like this. That is sound energy. And you guys might be able to drop your pencils or your pens like right now and then hear the sound it creates. So this is just the kinetic energy turning into the sound energy, right? So that's pretty neat. And if we were to use a battery to light a bulb, battery is considered a chemical energy. It's a different type of chemical energy. So if you were ever to light a light bulb, right, like in this picture over here right next to me, you would need a battery, right? Some source of electricity, right? So then that electric energy, which is a type of kinetic, that electric energy is going to make the light bulb light up, which is radiant energy or energy from light. So there's all of these different energy transfers. And notice that none of the energy transfers are losing or gaining energy. Energy isn't being lost. Energy isn't being transformed. You're not creating new energy. It's just transferring into different forms. And so energy transfers are possible because of, hint, it's a law that we learned about. I'm going to give you guys some time to write it down, what the answer is. And so then we'll see together. So energy transfers are possible because of, I hope you guys all said, the law of conservation of energy, right? Energy cannot be created nor destroyed, but it can be transformed into different forms and different types. Okay, so now this brings us to our next section, which deals with energy resources. We're going to learn about the renewable and non-renewable sources. So first of all, let's get into the non-renewable energy sources. So energy, as we all know, it can be stored in fossil fuels, and this is how we get our electricity. Now, non-renewable energy sources are not dependable because there are only a limited supply of them on Earth, right? And fossil fuels, they include natural gas, they include coal, and they also include oil or petroleum. And so most of us get our energy from these fossil fuels. Like these factories are using fossil fuels right now. Notice that there's a lot of pollution from it because when you burn coal, you have steam, right? And so the steam has a lot of energy. It's going into the atmosphere, right? And we rely on steam-powered energy sources. This is why coal is important. They also use natural gas like methane, and then there's also oil. And that's like in our gasoline, right? So when we want to drive a car, our cars are going to burn the gasoline or the oil, and this is what makes it move. So that's where we get most of our energy from. And the thing about fossil fuels is that they're super inexpensive and cheap. Even though there's like a little limited supply of them, they are still pretty inexpensive. The coal, like way more inexpensive than what we're going to explore later, the renewable resources. And so, even though these non-renewable resources are super cheap, they come with a lot of downturns, right? So most of the energy sources that we use have a variety of negative impacts. Pollution, right? So we're releasing so much steam into the air. Carbon dioxide, see those the carbon dioxide emissions from burning coal? You have carbon dioxide in the air, which results in climate change. And I'm sure you guys have heard of global warming. right? And so when there's too much carbon dioxide or pollution in the air, it's going to trap all of the heat on Earth. Okay, so have you guys ever imagined yourselves under a blanket, right? If you're under a blanket, you're going to get hot real quickly because all of the heat is being trapped. You can think of pollution in the same way. If you have a lot of gases or carbon dioxide in the atmosphere, it's going to trap a lot of heat, and this leads to global warming. And so the Earth is now a lot hotter, and this has a lot of impacts. Like here where I live in California, we have so many wildfires, and part of this is because of climate change and global warming. Now we have the temperatures are so hot that our forests are really susceptible to the heat, right? And they're going to catch on fire. And we have these ravaging wildfires that are destroying habitats, and it's really bad. And then if you go to the Arctics, you'll see that the polar ice caps are melting. And what lives there? We have polar bears living there in the Arctic. And now their habitats are being destroyed as well, right? And so as more ice is melting, our sea levels are rising as well. And so there are so many negative impacts that are associated with global warming. And this can all trace back to the use of carbon emission or fossil fuels, right? Like coal and the carbon emissions in the air. Next, we get into acid rain. So when chemicals are burnt, like nitrogen oxide and carbon dioxide, when those are released into the atmosphere, this is going to get into the clouds. And in the clouds, right, rain falls from clouds. And if you have polluted clouds and everything, it's going to get into the rainwater. And as it starts to rain, the pollution is going to be spread, and it's going to seep into the dirt and the soils, harming the plants. This can be really toxic. And it's also going to rain into our water supplies, right? And so our water supplies are going to be polluted as well. And these are really poisonous. So this is really bad for us. And now this also leads us to habitat destruction again, like with the acid rains destroying those soils. And more habitat destruction can result from clearing up trees to get the oil, right? Because oil's underneath the crust. It's like right in earth. So you have to dig up. And so in order to get the oil and the coal and mine for them, you're going to have to destroy a lot of trees, and now you're destroying habitats. And the final, really most important one is the damage to our public health. When we're breathing into the air, our lungs can get inflamed, right, because of all of the pollutants and the chemicals. And this is really bad for our health, right? We're not breathing in fresh air, and these chemicals are super dangerous. And our water supplies also, we're not going to be able to get clean water supplies. So this has so many negative impacts. Now, I want to go into the renewable energy sources now. And renewable energy sources are known as clean energy because not only are they dependable, like they can be replaced by nature, but they also give us clean air and water. One of the big things about non-renewable energy resources is that if you use up all of them, they're gone forever. Now, for renewable energy sources, on the other hand, nature can supply us with more of it. We're not going to run out of sunlight. We're not going to run out of wind. We're not going to run out of the waters. There's so much water in the earth. And so different types of clean energy involve biomass energy, geothermal energy, like from volcanoes, or the convection currents within Earth. Also, solar energy from the sun. We have wind power, right, which can spin wind turbines. In the picture over here, you see a wind turbine over there, and so it's going to generate energy from the wind, right? You see the energy becoming converted into electricity. And then the last one is cut off a little bit, but it says hydropower. And so this is energy from water currents, right? So if you had a little turbine, you could have water spin it based on the water currents flowing, and this is just a natural way to get energy. And so while this might raise the question, why don't we just get clean energy sources and renewable energy instead of using coal and those fossil fuels, right? Well, there's only one little problem with it. The only problem really is that they are pretty expensive. They cost a lot to make and manufacture, right? And so it's a lot harder to get renewable energy sources. You have to build these structures. And then again, these renewable energy sources aren't exactly perfect because you will still need some land space, right, to ourselves. We might destroy a little bit of habitats, but this is not as bad as the non-renewable energy resources. So ideally, it would be best for us to switch to clean energy sources because it can minimize the damages of pollution. You don't get pollution from clean energy resources. The only problem is when you make them. Like when you're manufacturing them in factories, then there's going to involve a bit of pollution. But afterwards, you have clean energy. And so this is a lot like a really good outcome. Now let's talk about the long-term effects of energy use in a society. So, first of all, why is it important to conserve energy? Well, again, I'm going to repeat this, but any energy generated has an impact on the environment. So, the production of renewable resources like solar energy, it does release pollutants, like when you're making those structures. And so, there's still a little bit of pollution that's going into the air. And when water is polluted from creating energy sources, marine life and public health is also harmed, right? Our drinking water gets contaminated. Soil becomes contaminated when it comes in contact with acid rain or polluted water. And we want to protect our environment for our future generations. And so by saving up our energy resources, we can minimize pollution. And so, what are ways we can conserve energy? What are some things we can do? Well, turn off the lights when you're not using it or when you don't need it. So, use like the light in your room, right, instead of keeping your lights on. Also, it's a lot better to do your chores by hand. So, you can hand wash your items instead of using a dryer. It's not might not be the most practical solution, but every once in a while, if you want to conserve energy, you can do this. Also, if you want to wash the dishes, wash it by hand instead of using the dishwasher. You can also use the air conditioner and heaters a lot less to save energy. Also, spending less time on electronics and watching less TV, you can do a lot of other things. You can read a book, you can do puzzles, there's so many other things you can do without electronics. You can also take shorter showers and keep your lights off during the daytime. And you could also dry your clothes in the sun by instead of always using a dryer. So those are some solutions, some really easy, simple solutions. Also, things as simple as turning off the water when you don't need it, when you're brushing your teeth, that kind of stuff. And so this brings us to the end of the lesson, and thank you all so much for listening. I hope you all have a wonderful rest of your day. Bye, everyone.